Week 8, Lesson A. Our goal: match graphs with situations to describe function features. Our agenda: we are going to do a warm-up. I'm going to have you match some graphs to a story. You're going to kind of make a guess, and then we will go over it. We're going to listen to graphing stories and match them up with their correct descriptors. And we're going to have a closure question. Our announcement this week: Lesson A, cumulative review, and then Lesson B this time will be a quiz. So you can be watching for those items in week 8 in your Google Classroom. Here's your warm-up. Each of these graphs show distances traveled from home. Graph A, B, C, and D are pictured. Notice time is the independent variable. Distance is the dependent variable. Notice the shape of the graph. They're all linear. Notice which way they are tilted. Which graphs go with the following statements? The person is not walking. The person is walking towards home. The person is walking away from home. What is happening in the graph you did not match? The person is not walking matched graph B. As time went on, the distance did not change. The person is walking towards home matched graph C. As time increased, their distance got shorter. The person is walking away from home, graph A. As time goes on, the distance increases. What is happening in the graph you did not match? Well, that was graph D. And basically, what it is saying is that at the same amount of time, you are in a whole bunch of different places at once. So you must be good at teleporting. Take a look at the graph. The independent variable is the number of tickets purchased. The dependent variable, cost of tickets in dollars. Notice this is a discrete graph. Buying tickets. A local movie theater has a graph for customers to see the total cost based on the number of movie tickets they purchase. At this theater, all tickets are the same price, no matter the age of the guest. Number 1, there are 6 people in George's family. How much did George's mom pay for tickets? Show how you found your solution. Number 2, what is the price of each ticket? Show how you found your solution. Number 3, if you go to the same movie theater with exactly $50, how many tickets could you buy? Justify how you found your answer. This is a graph about eating popcorn. Take a look at the graph. Notice that the independent variable is time eating popcorn in hours. The dependent variable, height of popcorn in bag in centimeters. So it looks like they are definitely eating some popcorn in this experiment because the height of the popcorn seems to be going down. This is a continuous graph. George's popcorn. George and his family are watching a movie. Each family member gets their own bag of popcorn. To the right is a graph of George eating his popcorn. Use it to answer the following questions. Include units for all answers. Number 1, what is the height of the popcorn in the bag before George starts eating? Number 2, what is the height of the popcorn in the bag after 1 hour? What is the height of the popcorn in the bag after 15 minutes? Number 4, at what point is the height of the popcorn in the bag exactly 14 centimeters? Number 5, at what rate does George eat popcorn during his movie? Number 6, the movie is exactly 2.5 hours long. If George keeps eating at the same rate, does George run out of popcorn before the movie ends or not? Justify your solution. Number 7, George wants to eat at a rate that if the movie was 200 minutes long, he would still have popcorn left. What is one speed at which he could eat so this happens? Take a look at the graph. Notice that the independent variable is time in hours. The height of popcorn in the bag in centimeters is the dependent variable. Helga's popcorn. George's sister Helga goes to a different movie. This graph represents the amount of popcorn she had at different points of her movie. Number 1, what happens 30 minutes into the movie? Number 2, when does she get more popcorn? How do you know? Number 3, when is she eating more quickly? When is she eating more slowly? Number 4, how long was her movie? What assumptions are you making to determine this? Your exit ticket. The graph below shows or represents a jogger's speed during her 20-minute jog around her neighborhood. Notice the dependent variable is time in minutes. The dependent variable, speed, miles per hour. Which statement best describes what the jogger was doing during the 9 to 12 minute interval of her jog? Was she standing still? Was her speed increasing? Was her speed decreasing? Was she jogging at a constant rate? The answer was the last one. She was jogging at a constant rate. The graph is horizontal, so that means there is a constant speed, a constant or the same y value or dependent variable.